In this lesson, we're going to talk about roots. So with a root, most commonly you've heard of a square root, but we have a number inside a bracket. Okay, so let's talk maybe about 25. Okay, we also have what's called an index, which typically goes right here in the hook. Now, when you don't have any number right there in the hook, as you've seen with the square root, that's because it's implied that it's a 2. So there's like this invisible 2 that sits here. Now, most students can tell me that the square root of 25 they know is 5. But do you know why? It has to do with this index right there. I want you to think about, how do you multiply to make 25? 25 is 5 times 5, which kind of relates to this answer, right? But how do we go from 2 5s to just 1? Well, it's because of that index. That index tells us how many bases we're looking for. Because if you think about this, 5 times 5, we just learned about exponents. How would I write that in exponent form? I would write this as 5 to the second power. Well, every time I get that exponent to match my index, I'm going to take the base outside, and it cancels what's inside. So what I have left is just 5, which you already knew was the square root of 25. So let's look at some others. I already did number 1 for you. Again, I want you to take 25 and break it down to its factors, which we knew were 5 times 5. I'm going to take those and I'm going to write them in exponent form using the exponent of my index. So what was my index here when it's implied? It's a 2. So I want to write this using an exponent of 2. So 2 5s would make 5 to the second power. Because that index is implied, I know that I'm looking for the exponent of 2, in which case I can move the base outside and cancel it inside. So the square root of 25 is 5. Let's try that with a different number. If I break down 81, I have 9 times 9, and I also know that 9 breaks down to 3. So if I were to write this with my prime factors back inside, what exponent do I want to use based on my index? My index is 2. So I'm going to create groups of 2 so I can write everything to the second power. So here I have 2 3s, so I can write that as 3 to the second power. Here I have another 2 3s, so that's another 3 to the second power. Every time I have an exponent of 2, I can move that base outside. So here is one base I can move outside, and then it cancels inside. Here's another base I can move outside, and then it cancels inside. So outside, I currently have 3 times 3. And 3 times 3 is 9. Let's try one more example. 36. I like 9 times 4 for 36, although there are many ways you can do it. What I'm trying to do is get down to those prime factors. So 9 can break down to 3 times 3, and 4 can break down to 2 times 2. These are prime numbers. So now I want to put them back into a square root, and I'm looking for pairs or groups of what? Because what was my index? My index is 2. So I'm looking for pairs of 2. So here I have 3 to the second power, and I can also write this as 2 to the second power. So now, because I have this second power, I can move the base of 3 outside, and I can move this base of 2 outside. So I have nothing left inside the square root. Square root is gone. What's 2 times 3? So the square root of 36 is 6. Now, so far we've talked about just perfect squares, but you don't always get a perfect square. Let's talk about 32. To multiply and get 32, most students would tell me 4 times 8. Again, there's a few other ways you could get there. We're just going to break this down to its prime factors. Just like that. Notice how I always cross it off every time I break down another branch? I don't want to get confused and use a number more than once. So, now, what was my index? My index is 2. So again, I'm going to use an exponent of 2 as I rewrite this. So I have 2 to the second power. I have another 2 to the second power. And then I have this 2 all by itself. It doesn't have an exponent of 2. Now remember, when I pull these outside, I'm looking for an exponent of 2 because of the index. So whenever I see an exponent of 2, I'm going to bring what outside? The base. So my base of 2 will come out here, and this cancels. I have another base of 2 that comes outside, and then this cancels. But this time, can I bring this 2 outside? No, it doesn't have an exponent of 2. So I have to leave it inside the radical. So this is going to stay the square root of 2. But then outside, what will I have? 2 times 2 is 4. So this time, my answer still has a square root left in the answer. We call this 4 radical 2. This right here is your radical. Let's look at some problems that have an index other than 2. For example, in problem number 5, what is my index? This time my index is 3. Now the process is all the same. So I'm still going to break 27 down to its prime factors. So 27 is 3 times 9, and 9 is 3 times 3. So when I rewrite this with an exponent, what exponent do I want to create? Again, this all goes back to our index of 3. So I need 3 numbers. So here I have 3 3's, so my base would be 3, and my exponent, of course, is 3. And I also need to put that index back on my radical. I know, there's a lot of 3's in this example. So again, I'm looking for that exponent of 3, which I have here, so I can pull my base outside, and this cancels. I no longer need the radical, so the cube root of 27 is just 3. We call this a cube root or a third root because of that index being 3. So example 6, we're looking for the third root or the cube root of 64. Same process. 64 I know is 8 times 8. 8 is 2 times 4. And 4 breaks down to 2 times 2. So here's my radical. I'm looking to create an exponent of what? 3. So here I have 3 2's. So I can write this as 2 to the third power. Here's another 3 2's. So I can write that as 2 to the third power. What can I pull outside? I can take anything with an exponent of 3 outside. So here I have 2 to the third, so I'm going to bring the base outside and it cancels. Again, I have that exponent of 3, so I have another base of 2 that I can pull outside. And then these multiply. So what is 2 times 2? 4. Do I have anything left inside the radical? No, it cancels. Let's try another one. All right, problem 7. What is our index? It's 3. Perfect. So, start by breaking down 216. 6 times 36, 3 times 12, 4 times 3, this is 2 times 2. Again, most of these you could choose lots of different numbers. You're just trying to get down to those prime factors. So at the end, on a big number like this, it might be helpful to take these prime numbers and make sure they really multiply back to make that original number inside our radical. So we have 2 times 3 times 3 times 2 times 2 times 3. Make sure when you multiply all those back out that it makes 216. In this case, it does. What is the exponent that I'm trying to create inside my radical? Remember that our index was 3? So we're trying to create an exponent of 3. So if I'm starting with the 2's, how many 2's do I need in order to create 2 to the third power? I need 3. So here's 1, 2, and 3. Perfect. Those are gone. Do I have anything left? Yeah, I still have these 3's. How would I write those with an exponent? 3 to the third power. Again, that's what we're looking for and trying to create because of that index, which, by the way, we need to put in the hook of our radical. Okay, so what can I pull outside of the radical? I can pull out a base of 2 and a base of 3. Again, this was because they have an exponent of what? Of 3. Is there going to be anything left inside my radical? Nope, not a thing. So our final answer is 2 times 3 is 6. Let's look at number 8. Remember, an index could be any number. I'm trying to keep it small for you so that it's easier to practice with. But you could have an index of any number. It just changes what your exponent is. So let's look here. We have the 4th root of 16. So what's my index? It's 4. So the first thing we have to do is create our prime factors. So 16 is 2 times 8. 8 is 2 times 4, and then we have 2 times 2. So what should my exponent be? What am I trying to create? We want an exponent of 4, which means I need how many 2's? 4. And do we have 4? 1, 2, 3, 4. We do. So I can write this as 2 to the 4th power. Do I have anything left? No. Don't forget to put your index back in the hook of your radical. Now, does my exponent match my index? Yes. So I can take what outside? Take the 2, the base, outside. It cancels. Is there anything left? No. So what's my final answer? 2. Perfect.